Alright, good day everybody. I hope you've had a lovely 24 hours. We have been looking at trig for a couple of days now, and we're going to continue working with our trig, but today we're going to be looking at how trig applies to the unit circle, or at least to start an introduction to the unit circle. Alright, so what is the unit circle? Alright, so the unit circle basically, in our terms, is simply a circle whose center is on the origin and has a radius of length 1. A circle whose center is on the origin and has a radius of length 1. Now, we're going to spend the next couple of days talking about the unit circle, but before we actually dive head deep into the waters of the unit circle, we got to understand a couple of the vocabulary words. So today we're going to focus on the vocabulary, and we're going to start on maybe one or two pieces of the pattern of the unit circle. So today we're going to look at the vocabulary, and then we're going to look at finding the degrees of the unit circle, and also converting to radians. Alright, our first vocabulary word that we're going to look at today is an angle in standard position. What exactly is an angle in standard position? Well, angle in standard position has two characteristics. The first one is that the vertex is on the origin, and our second characteristic is that the initial side starts at 0 degrees. Alright, so here we have our coordinate plane. So let's see what angle in standard position is going to look like. Alright, so it's going to start at 0 degrees. So here our initial side is at 0 degrees. Now remember that the quadrants, each quadrant is 90 degrees. So if that's 0, this is 90 degrees. This would be 180 degrees. That would be 270. And completing the whole rotation, we'd end up at 360 degrees. Okay. Alright, so your initial side starts at 0 degrees, and then your terminal side is going to be this right here. So this is your initial side. And this side right here is your terminal side. Alright, so think about the root word of terminal. Root word of terminal is terminate. And we know that terminate means it comes to an end. So this is where the angle comes to an end. Now, notice that this angle here starts at 0 degrees and it opens to the left. When it opens to the left, we call this counterclockwise. CCW, counterclockwise. Okay. So when you have an angle that has a starting spot and opens to the left, it is opening counterclockwise. And usually if we're talking about angles in standard position that open counterclockwise, they are usually your positive angles. If we have an angle that has its starting position and opens to the right, then that is known as clockwise, because that's the direction that the clocks on the hands on the clock move to the right. So that is clockwise. And when we're talking about angles in standard position, we reserve that usually for your negative degree angles. Alright, so here for problems 1 through 4, we have a couple examples to draw angles in standard position, so let's do that. Alright, starting with number 1. Now remember, this 0 with a line through it's called theta. And all theta is, it's a variable. It's a Greek letter, but it's a variable that represents any given value. So here theta is 45 degrees. Now sometimes I might ask you, what quadrant would that terminal side be in? So let's talk about the quadrants again. I know this is 0, this is 90, this is 180, 270, and 360. All right. Now, just like your degrees are counterclockwise when they're positive, your quadrants are also counterclockwise. So this quadrant right here is actually quadrant 1. This is quadrant 2. This is quadrant 3, and this is quadrant 4. Now, we know that the angle is going to start at 0 degrees. So where does 45 fall? Is it between 0 and 90, 90 and 180, 180 270, or 270 and 360? Obviously 45 is between 0 and 90, so it would fall in quadrant 1. So we're going to draw our angle right here. 45 is about halfway between, well, it is halfway between 0 and 90. So we're just going to draw this in. And we got our angle of 45 degrees. Now, this one was opening to the left, so that again was counterclockwise. Alright, for number 2, they give us 150. So we got 0, we've got 90, we've got 180, and I know 150 is between 90 and 180, so I know that 150 is going to be in quadrant 2. So let's draw that in. Right, here's our initial side. Alright, 150, well 150 is closer to 180 than 90, so we're just going to kind of guesstimate what 150 might be. So this right here is 150 degrees. Our terminal side was in quadrant 2. Now again, this opened to the left, so this was counterclockwise. Alright, now in looking at example 3, what do you notice is different about example 3 than in examples 1 and 2? Right, we have a negative right here. Since this is negative, that means that this one, instead of opening counterclockwise, is actually going to open clockwise. Because it is negative, it's going to change our degrees. Okay, so this is still 0 degrees, but instead of going counterclockwise, we're going clockwise. So this is 90, but it's not positive 90, it's actually going to be negative 90. This is going to be negative 180. This is negative 270. And this is negative 360. With that being said, where is negative 120 going to fall? Well, it's going to fall between negative 90 and negative 180. So it's going to fall in quadrant 3 for the terminal side. So it still starts at 0 degrees. All right, and 120, it's going to be a little closer to 90. So here's our negative 120. All right, let's let number 4 be a U try. So pause the video for about a minute, and everybody do number 4. All right, so let's see how you did. All right, 227 is positive, so we know we're going counterclockwise. So let's see, we got 0, we have 90, we have 180, we have 270. Well, 227 is between 180 and 270, so it's going to fall right here in quadrant 3. So drawing this in, our initial side starts at 0 degrees. All right, and 227 is probably a little closer to 180 than it is to 270. So this is 227 degrees. So hopefully you did well on that, and hopefully you got a good understanding of what an angle in standard position is. All right, our next vocabulary word are coterminal angles. All right, so think of the prefix co, like co-worker. Co-workers are people that you work with. You work together with those people. So the prefix co means together. So coterminal, they terminate together. So these are angles that stop at the same location. So coterminal angles are angles that terminate or stop at the same position or place. All right, so looking at our example right here, notice we got an angle that measures 100 degrees. All right. Let's say that we had an angle that started at 0 degrees, it went a complete rotation, but then it continued to the same spot that 100 stopped at. Okay, so let's talk about what this would measure. This angle here in pink. All right, if we start here and complete a whole rotation, what is that measure of a whole rotation? Right, 360. Now, so right here, again, we spun a whole circle, so that's a 360, but then we went an additional what? 100. So we start off with 100 degrees, but now we did a whole rotation plus that 100, so that is actually 460 degrees. Since the 100 degree angle and the 460 degree angle stopped at the same spot, they are called coterminal angles. Let's say that we had an angle that started at 0 degrees. We got one rotation, then it went another rotation, and then it continued to that same stopping spot. What would that be? Well, one rotation is 360. Another rotation would be an additional 360. So 360 plus 360 is 720. But then, so two circles, two complete rotations is 720. So then adding in that additional 100 degrees would make that 820. So 100 degree angle, a 460 degree angle, an 820 degree angle. They all stop at the same spot. So these are called coterminal angles. Now, ask yourself, what do you do to go from 100 to 460? Well, we added 360. What do you do to go from 460 to 820? Well, once again, we add 360. So basically, in order to find coterminal angles, all you're going to do is either add or subtract 360 degrees from your original angle, depending on if you want to go above that angle or if you want to go below that angle. You're either going to add 360 or subtract 360 from your given angle. Alright, so 5 and 6, we got some examples of how this is going to be presented to you. It's asking you to find the coterminal angles on the interval negative 800 to 1000. So remember that when we have brackets, this is your interval. So it wants to know what coterminal angles will fit for 180 and negative 115 between negative 800 and 1000. Okay. So we're going to add 360 and we're going to subtract 360. Because 180 is in between these two values right here. So I know I can add 360 a couple of times and subtract 360 a couple of times. So let's start off with our addition. Okay. Alright, so we're going to take our 180 and we're going to add 360 and see what our coterminals angles are going to be. So for this, I'm just going to use Desmos. Excuse me. Excuse me. Alright, so we're going to put in our angle, 180, that's the angle that we're starting with, and I'm going to add 360. So we get 540. So our first coterminal angle is 540 degrees. And then I'm going to add another 360, and I get 900. And 900 is still between negative 800 and 1000. I'm going to add another 360. Well, I get 1260 degrees. Well, 1260 degrees is beyond 1000, so that means I can't use 1260. So now that I can no longer add 360, let's see what we get when we subtract 360. Okay. So starting with my 180 again, so you always start with the angle that you're given, and I'm going to subtract 360, and I get negative 180. Alright, so then we're going to subtract 360 again, and we get negative 540. Well, negative 540 is still between these two interval values. So negative 540 is another coterminal angle. Let's subtract another 360. We get negative 900. Well, negative 900 is beyond negative 800, so I cannot use that. So these are my four coterminal angles with 180. That's between negative 800 and 1000. Alright. So let's let number 6 be a U try. So let's take about a minute for you to add 360 a couple of times and subtract 360 a couple of times and see what you get. Alright, so let's see how you did. We're going to come in here, we're going to add 360 a couple of times. So our angle that we're starting with is negative 115. So we got negative 115. And we're going to add 360. So our first coterminal angle is 245. We're going to add 360 again, and we get 605. We're going to add 360 again. we get 965, which is still within our limit. All right, and if we add 360 one more time, obviously we're going to be over our limit of 1,000 degrees. So we can't use that 1325. Now we're going to do the same thing, but we're going to subtract 360. So we got negative 115 minus our 360. Our first angle is negative 475. We're going to subtract 360 again, and we get negative 835, but negative 835 is beyond the negative 800. So negative 475 is going to be my only negative coterminal angle within these boundaries here. Okay, so again, coterminal angles are simply angles that end at the same spot. You're either going to add 360 or subtract 360. All right. Our next vocabulary word is a reference angle. Now, I would say out of the vocabulary words that we've done so far, this is the one I see students struggle with the most. Okay. All right, a reference angle is simply an angle formed by the terminal side and the x-axis. Basically, you're going to look at the angle that is straight back to the x-axis. Now, before we actually go in here and find the reference angles in these examples here, let's talk about where these angles end. Okay. All right. This terminal side is in quadrant 2. This terminal side is in quadrant 3. This terminal side is in quadrant 4. If you notice, I don't have an angle for quadrant 1. And that is because any angle in quadrant 1 is its own reference angle. Okay. All right, so let's see what a reference angle is. Okay. What a reference angle is from the terminal side to the x-axis. So this one right here is the reference angle. From the terminal side and the x-axis. So this one right here is your reference angle. From the terminal side to the x-axis. So this one right here is your reference angle. You're going to be presented with an angle, and you're going to be asked to find the reference angle for that angle. So if you think about it, from here to here, we are being told this is 150 degrees. And they want to know, what is this reference angle right here? So we've got to find this reference angle right here. Well, this is 180. This right here stops at 150. So if you're going from 150 to 180, how many degrees is that? Well, that would be 180 minus your 150, and that would be 30. So this has a reference angle of 30 degrees. All right, so right here the x-axis is at 180, but my reference angle, my original angle is 225, so this stops at 225 degrees. So to go from 180 to 225, how many degrees is that? Well, you know when you always subtract, you do bigger minus smaller. So my bigger angle is 225 minus my 180. and that's going to give us 45. So your reference angle here is 45 degrees. Alright, for our last one right here, we're told we got 300 degrees. So this terminal side stops at 300 degrees. But this angle right here, we're not going to say 0 because we're looking at almost a whole rotation. We're going to say this is 360. So we want to know, what is the reference angle right here? Well, our bigger angle is 360, so we're going to say 360 minus the smaller of 300. So we get 60. So the reference angle here is 60 degrees. You're going to have to be able to do this. What is the angle from the terminal side to the x-axis? That is the reference angle. If you have to highlight it, I think it really helps if you highlight it to see what the actual angle is that you're working with. So like for example, if I ask you what is the reference angle of, I don't know, let's say 170. Alright, so visualize what 170 is. Alright, 170, let's see, this is 180, so 170 is probably right about here. So if that's 170, and this is 180, to go from 170 to 180, it's going to be 10. So this little angle right here would be 10 degrees. Alright. Now, I said that we didn't have a quadrant 1. So let's see what happens with a quadrant 1. All right, let's say that we were given an angle that was, I don't know, let's say 52 degrees. Well, this one's going from here to here, so it's going from 0 to 52. Well, what's the measurement of the angle that goes from 0 to 52? Well, it is 52. When an angle is in quadrant 1, it is its own reference angle. So if we had an angle that was, I don't know, 84, what's the reference angle for 84 degrees? Well, it would be, from 0 to 84 would be 84 degrees, so it would be 84. All right. Let's throw one more in there. Let me give you a little U-try. Alright, so let's say that we had an angle that was 279. What is the reference angle for 279 degrees? So take about a minute. Figure it out real quick. Alright, so let's see how you did. 279, well this is 270. 279 is going to be right about here. So that's 279. So going from the terminal side to the x-axis, well that would be 360 right there. So 360 minus 279. So let's see. 10 minus a 9 gives us 1, and 15 minus 7 gives us 8. So that would be what? 81 degrees. So your reference angle would be 81 degrees. Alright, so now we are going to actually begin our journey with the unit circle and the patterns. Okay? So the first thing we're going to do with the unit circle is we're going to find the degrees. Okay, there are 3 things that we're going to do with the unit circle. Okay, we're going to have to be able to determine the degree. We're going to have to find the radian measures. And then we're going to have to find the ordered pairs. Now, the degrees are really easy. Okay. Now, as you're preparing to write this down, let me forewarn you about something. All of our quizzes have been open note. There are 2 quizzes that are not open note, and those happen to be in the trig units. And the first one is the unit circle. I'm going to expect you to be able to do this without using any notes. So you better learn the pattern. But the pattern is very easy to learn. Alright, so if you notice here, we've got our quadrants. Alright, here's our x-axis, and here's our y-axis. The unit circle has this center at 0, and it has a radius of length 1. So this is just like we were doing a while ago with the quadrants. We need to measure the angles. Okay, so let's do the easy angles first. Alright, ready? Alright, so right here we're starting at 0 degrees. So this right here is going to be 0 degrees. This angle right here, we know it's going to be 90 degrees. This angle right here is 180 degrees. This angle right here is 270 degrees. And then when we complete that rotation, it is 360 degrees. All right, these right here are called the quadrangles. I want to say quadrangles. I've heard it said different ways, but basically it's the angles of the quadrants. Okay, so those are the easy ones. We all know those. We've worked with those before. But now we want to find all the other angles that are the main angles of the unit circle. And if you notice, each quadrant has 3 angles. Okay. These are the 12 angles measurements that we need to be able to know by heart. And again, it's really easy because it is a pattern. Alright, so I want you to write this down. 30, 15, 15, 30. 30, 15, 15, 30. 30, 15, 15, 30. 30, 15, 15, 30. Notice it's the same pattern and it repeats all the way around. If you know this pattern, you will be able to find your degrees. Alright, so let's see how this pattern is going to work. Alright, so we're going to start at 0. 0 plus 30 is 30. So this first angle right here measures 30 degrees. 30 plus 15 is 45. So this second angle is 45. 45 plus 15 is 60. So the third angle measures 60. And then 60 plus 30 is 90. 90 plus 30 is 120 degrees. 120 plus 15 is 135. 135 plus 15 is 150. 150 plus 30 is 180. Hopefully by now you're kind of starting to see how the pattern works. 180 plus 30 is 210. 210 plus 15 is 225. 225 plus 15 is 240. 240 plus 30 is 270. 270 plus 30 is 300. 300 plus 15 is 315. 315 plus 15 is 330. And 330 plus 30 is 360. This is how you find the degrees of your unit circle. You need to be able to do that without notes, without the internet, without your phone, without anything. You need to know how to do that. Okay, so that's our degrees. All right, now we're going to come in here and we're going to find the radians. Okay, we're going to convert everything to radians. Now, this is pretty easy, but before we actually do the conversions, I want to tell you about what a radian is. Okay, a radian is the distance traveled divided by the radius. Now, that makes absolutely no sense to us, right? Basically, what the radian is when you take the radius, and you bend it and put it on the circle. The radius has been bent and placed on the circle. The radian is the length of the radius that's been bent and placed on the circle. So basically it's the length of the radius, but it's been bent. A radius is straight, a radian is bent. Okay. Alright, so looking at this chart right here, converting between degrees and radians, very, very easy to do. Alright, if you want to go from degrees to radians, you're going to multiply by pi over 180. So if you're given something in degrees and they want you to change it to radians, you multiply by pi over 180. If it's in radians and they want you to change it back to degrees, you're going to multiply by 180 over pi. Now both of these have a 180 and both of these have a pi. So let's talk about how to convert. Alright, so here we've got 90 degrees and we want to convert it to radians. So we're going to take that 90 degrees and we're going to multiply by pi over 180. This is going to give us 90 times pi, which is 90 pi, and then bring over the 180. Well, 90 over 180 can be reduced. 90 goes in the 91 times, so we get 1 pi or just pi, and 90 into 180 is 2. So this is actually going to reduce to pi over 2. Alright, for our next example, we've got radians, and we want to convert it back to degrees. So we have 7 pi over 6. Now, we know that in order to have a degree, it's not going to have a pi symbol in it. So the way that I always did this when I first had to start teaching this is I asked myself, if I put a pi right here, pi times pi, the pi's are not going to cancel out. And I know degrees are not supposed to have pi's. So that let me know that I really needed to put the pi on the bottom because anything divided by itself would give you a 1. So basically we say it cancels out. So that's how I always learned that the pi should go on the bottom when you're converting back to degrees. So as I just said, the pi's cancel. And we're going to come right here and we're going to say 7 times 180. So I'm going to go to my Desmos, my calculator, and do 7 times 180. That gives us 1260 over our denominator of 6. So now we need to divide that by 6. So 1260 divided by 6 gives us 210. So 7 pi over 6 as a degree is 210 degrees. Alright. Let's do 2 more together and then I'm going to let you try these on your own right here. Alright. So here we're given degrees. 200, and we want to convert that to radians, so we're going to multiply by pi over 180. Alright, so I'm getting ready to show you a shortcut. Whenever you're converting from degrees to radians, you notice basically each time we're going to divide by 180. So if we just come right here on Desmos and we say 200 divided by 180, it's going to give us a decimal. But we're going to come right here. You see that little fraction button? We're going to hit that fraction button, and it gives us our fraction, 10 over 9. So no, this is actually going to end up being 10 over 9, and then you attach the pi. Never put pi in Desmos when you're trying to convert. Okay. So again, all you do when you're changing degrees to radians is just you divide. So like right here, I would have said 90 divided by 180. Hit that fraction button. And I get 1/2, or 1 pi over 2. Okay. All right, for our next one, we've got radians, 5 pi over 4, and I know it's a radian because it's got a pi in it. And I want to convert it, so I'm going to multiply by 180 over pi, because remember, we want the pi's to cancel. So then, I'm just going to put this in Desmos. 5 times 180, because numerator times numerator, divided by denominator 4. And we get 225. Alright, so pause the video here for about 3 minutes, and I want y'all to do these 4 right here real quick. Okay, so if you'll check your answers and see how you did. Now, notice right here, I starred this one right here. Notice this is in radians, but we don't see a pi symbol. So what happened right here is that they included pi. They went ahead and multiplied by a pi. You usually don't multiply by a pi unless they tell you to round. If they tell you to round, then you're going to multiply by either 3.4 if they say use 3.14, or if they just say round, you actually use the symbol pi. And right here, you see your symbol for pi. So what we have to do right here is we have to actually multiply all this out. So I'm going to say 5 times 180, and we are going to actually divide by pi. Oops. And the reason why is because pi was not given to us here. It's already included in that part of the answer. They multiplied pi already. Okay, so we get 286.5 basically. And that's how we got this right here, 286.5. Alright, so now that we know how to kind of know how to convert, we're going to come back right here to our unit circle, and we're going to convert all of these to radians. And then after we convert the radians, we can call a day on this. Tomorrow we'll learn about the last piece, the ordered pairs, because that takes quite a bit to learn how to do those ordered pairs. Alright, so again, all we're going to do each time is we're going to divide by 180. So 0 divided by 180 is still 0, so that would be 0 pi. Most of the time, you're not even going to see that 0 pi written out, but we're just going to put it there for the time being. Okay, so this would be 0 pi. And again, most of the time you don't even see that. Alright, so now we're going to do 30. So we're going to say 30 divided by 180. Hit that fraction button, and we see 1/6. So that's going to be 1 pi over 6, or just plain old pi over 6. For 45. Okay, I'm just going to keep that right here. I'm just going to change the 30 to 45. So we say 45 divided by 180. We get 1 pi over 4, or just plain old pi over 4. For 60, I'm going to change that 45 to a 60. And we get 1/3. So that's going to be 1 pi over 3, or just pi over 3. 90 divided by 180, well, that's 1/2, so that's going to be 1 pi over 2, or just pi over 2. Now we've got 120. So coming here, just changing out my numerator. 120 divided by 180, we get 2/3. So this is going to be 2 pi over 3. 135, so let's change that numerator to 135. We get 3/4. So this is 3 pi over 4. 150, so let's change that numerator to a 150. We get 5 over 6, so we get 5 pi over 6. And notice again, I'm not putting pi in the calculator. You do not want to put pi in the calculator. 180 over 180 is 1, so we get 1 pi, or just pi. Alright, so what I want you to do, I want you to take about 3 minutes and I want you to finish the bottom half of the circle. Change all these degrees to radians. So I'm going to pause the video here for about 3 minutes. Okay, check your answers. And as you're doing this, again, remember, I will be giving you a quiz on the unit circle. You will not be able to use your notes. You will not be able to use your computers. It will be on paper. Okay. Alright, so again, the pattern for the degrees is 30, 15, 15, 30. The pattern to change degrees to radians is simply you divide the degree by 180, reduce it, and then attach pi. Alright. So you can ask the sub to pause the video, or if you're watching this independently, you can pause the video, finish copying the answers down, and then submit your notes.